A capacitor is similar to a battery in that both store electrical energy, but a capacitor is a much simpler device that can't produce new electrons. It only stores them. However, capacitors can do things a battery can't, as we will show here. For the purposes of this animation, we'll focus on different parts of the current propagating through the wires at different times. When we close the switch, electricity immediately runs throughout the circuit. Although the convention is to think of electrical current as moving from positive to negative, electrons actually move from negative to positive, as we represent here with yellow particles. As you can see, the battery is not much good at powering this motor to lift this weight, because it discharges gradually, much more slowly than would a capacitor with the same charge. Here we'll learn why a capacitor is much better suited to such a task than a battery. Like a battery, a capacitor has two terminals, positive and negative. Inside the capacitor, the terminals connect to two metal plates separated by an insulator that keeps the plates from touching each other and allows them to hold opposite charges, maintaining an electric field. Capacitors can be useful for storing and quickly discharging electricity, so you can power, for example, an electric motor as we'll show here. First, we need to charge the capacitor. By closing the switch, we create a circuit that includes both the capacitor and the battery. Electrons flow from the battery to the capacitor, where they are stored. Here, a yellow glow represents the increasing charge held by the plate. For every electron gained by that negative plate, an electron is lost by the positive plate, maintaining the capacitor in equilibrium. Here, the red glow represents the positive charge held by the plate that increases with each parting electron. The capacitor continues to charge until it attains the voltage of the battery charging it. Now that the capacitor is fully charged, let's put all that stored energy to use. By connecting it to a new circuit, we can power a small motor. This electrical current powers the pulley to lift the weight until the charge dissipates. The electrons on the capacitor's negative terminal are drawn to its positive terminal. They rush along the path that leads there, straight through the motor. Let's watch this again. Even though the battery and the capacitor attempted this task with the same amount of charge, only the capacitor successfully powers the motor lifting the weight, because it discharges much more quickly. This feature makes capacitors useful for powering things that need a quick surge of energy, such as flash bulbs and cameras, and starter motors and audio amplifiers in your car.